Okay, Trig kids, this is my next section, section 7.2. It's not nearly as bad as section 7.1. And we are going to be doing some sum and difference formulas for our basic trig functions, sine, cosine, and tangent. So here we go with section 7.2. Now, on section 7.2 here, before I get into practice problems, we need to learn some sum and difference formulas. These sum and difference formulas are on PowerPoint slide number 8. That again is in your class folder drive. So look there, and they're also on that Trig cheat sheet that I uploaded to the class folder drive as well. So look in those two places for the sum and difference formulas. So I'm going to write the first one up here. It deals with sine. So if you have sine of x plus y, you can split that out into sine x times cosine y plus cosine x times sine y. Now, this actually works for both sum and difference. I'm actually going to put a little minus under here. This works for both the sum and the difference. So this is one of our sum formulas. Now, let me give you an example of this, and this is actually problem 1 in your homework. So an example of this is sine of 75 degrees. Sine of 75 degrees, we're going to split that up. We don't know the exact answer to this. We could poke it in our calculator and get some decimal approximation, but that's not what they want. They want an exact answer. So we are going to split this up into sine of 45. Sine of 45 degrees plus 30 degrees. Now, if I split that up into 45 and 30, then I can use my sum or difference formula that I have up there in the box right above it. So this is going to equal sine of 45 times cosine of 30, and I should put the degree symbol there, plus cosine 45 degrees times sine of 30 degrees. Now that is, again, using the formula that I have in the box. So you can use your unit circle that we filled out back in chapter 5 or whatever, but we know our basic trig functions here. Sine of 45 degrees is root 2 over 2. Cosine of 30 degrees is root 3 over 2 plus cosine of 45 degrees, all the 45 degrees ones are the same, we know, is root 2 over 2, times sine of 30 degrees is 1/2. Okay, so then if we multiply the left and the right, we get root 6 over 4 plus root 2 over 4. Now, I'd be happy with that. I don't know. My guess is that WebAssign may want you to combine that into 1. So root 6 plus root 2 all over 4. That would be your final answer. And again, this is problem number 1, or it's my problem number 1 on my homework, but it's a good demonstration, if you will, of that first sum formula for sine. Now, moving right along, the next sum formula is cosine. So if we have cosine of x plus y, okay, now this one looks a little different than the sine, okay, so be aware here. This is cosine x cosine y minus sine x sine y. Now, this is the sum formula again for cosine. Cosine x plus y is cosine x cosine y minus sine x sine y. Okay, now let me also say that's the sum formula. The difference formula, if you change this sign to a minus, you change this sign in here to a plus. That's the only thing that changes between the sum formula and the difference formula. And again, let me do kind of the same practice problem. This is actually problem number 4 in my homework. Same kind of deal. If I have cosine of 75 degrees, I can split that up into cosine of 45 degrees plus 30 degrees, and then I use my sum formula. So my sum formula would tell me this is cosine of 45 times cosine of 30 minus sine of 45 times sine of 30. Okay, now cosine of 45 degrees. We know, okay, cosine of 45 degrees is root 2 over 2. Cosine of 30 degrees, root 3 over 2. Sine of 45 degrees, again, root 2 over 2. And sine of 30 degrees, everything here is in the first quadrant, so it's all positive. Sine of 30 is 1/2. So again, this gives us root 6 over 4 minus root 2 over 4. Okay, and again, if I'm betting, Webassign would want it written as 1 fraction. This would be it. Root 6 minus root 2 all over 4. Now, if you remember, the one we did for sine was root 6 plus root 2 all over 4. Okay? This is just an example of the sum, or we could use the same process for the difference formula for cosine. Okay, now, the other thing we need to talk about is even and odd functions. Now, I alluded to this in, I believe it was part C and D, maybe, of section 7.1, but if we talk about even and odd functions, I want to reiterate that sine of negative x is negative sine x. And think about this in terms of the unit circle. If you have a negative degree measure, you're going down, right? You're going under the x-axis. So that is going to give you a negative sign. Okay, because remember, sine is your y-axis. So that's going to give you a negative value. That means that this is an odd function. Okay, cosine of negative x is just cosine of x. It is an even function. It is even because it is symmetrical about the y-axis. Think of your cosine curve. Okay, if you flipped the board or flipped your paper, folded it, if you will, on the y-axis, they would lie on top of each other. So it is an even function. Okay, if you find the cosine of a negative degree measure, something that's below the x-axis, you're going to get the exact same value as if it was above the x-axis, because cosine is positive in the first and fourth quadrants. Cosine is your x-axis. And then tangent. Tangent of negative x is negative tangent of x. So again, that makes it an odd function. And again, same reasoning with sine. Okay, you pull the negative out in front, and that makes it an odd function. So here's an example. This is actually my number 2. I have sine of 285 degrees. Now, as I was thinking of this, I kept thinking of any combination of degree angles that I knew that would either add to or subtract to 285. So I was thinking 270 plus 15. Well, I don't know what 15 is. I mean, the ones that we have exact answers to are 30, 45, and 60. And then, of course, your 90, 180, 270. But we have just your basic exact answers to the 30, 45, 60 degree angles. So I couldn't find any that jumped out at me that would work here. So I got to thinking, if this is on our unit circle, 285 would be, here's 90, 180, 270, 285 would be about right here. Okay? So all the way around, 285. Now, think about that in terms of negative. Okay? If this is 285 going around the positive direction, what is this going down the negative direction? That is negative 75. Okay? So sine of positive 285, remember if we add, first of all, 285 plus 75, we get 360. So sine of 285 is the same thing as sine of negative 75 degrees. Well, what did we just learn with our even and odd functions? Sine of negative 75 is the same thing as negative sine of 75 degrees. Well, we just found out that very first example I worked 2 screens ago is that negative sine of 75. We already did sine of 75. So this is just going to be minus, our answer that we got was root 6 plus root 2 divided by 4. That would be my answer, and because we had already found sine of 75. Again, that was 2 screens ago. Okay, so go back to the very first example. So that is another way you can do these. Okay, think unit circle. Now, let's do the same thing here then with cosine of 285. So cosine of 285, doing the same logic that we just did with sine, would have to be cosine of negative 75 degrees. I should have put my little degree symbol in there. Now, the nice thing about cosine is that cosine is an even function. This is the same thing as just cosine of 75 degrees. Okay, whether it's negative 75 or positive 75, in the first quadrant and the fourth quadrant, cosine is still positive, so it doesn't matter. So if we used our sum formula, which we already did, again, I did that 2 screens ago, I believe, for cosine of 75, we found that to be root 6 minus root 2 divided by 4. Okay? I like that all 4 of these kind of go together so you can see how both the sum formulas work and how the even odd functions work, and can really reduce your grunt work on these if you remember your even and odd function rules. Okay? Now, keeping going. Let's look at a formula for tangent now. The sum and difference formula for tangent, it's a little trickier, so hang with me here. Tangent of x plus y equals, this is going to be a fraction, so hang tight here. This is tan x plus tan y divided by 1 minus tan x times tan y. So this is your formula for the sum of the tangent function. Now, once again, this goes hand in hand with the difference formula. So the difference formula, if this happens to be a minus in here, then both of these signs change on the right side. This becomes a minus on the top, this becomes a plus on the bottom. Okay, so you have to think about your signs going from either the sum formula to the difference formula. Now, here's an example of the difference formula. What if I have tangent of 15 degrees? Now, again, what I'm looking for using my sum and difference formulas are something that I can use the degree measures of like 30, 45, 60, 90, 180, 270, the normal ones, okay? So obviously 15 I can get by taking 45 minus 30. So this is going to be tan of 45 degrees minus 30 degrees. Now, this one, we're actually using the formula right above us in the box, only we're using the red notations. We're using the difference formula. So this is going to equal tan 45 minus tan 30 over 1 plus tan 45 times tan 30. Okay? Now, to find your tangent function, a couple different ways you can do it. If you have a nice Casio calculator, make sure it's in degree mode. Okay? Or you can look it up. Remember, tangent is sine over cosine. So you can look it up on your unit circle and take the value of the sine at that degree measure over the value of the cosine at that degree measure and then reduce. I'm going to just jump in here and put the values that I know these to be. So tangent of 45, remember tangent sine over cosine. Sine and cosine are the same thing at 45 degrees, so that just leaves me a 1. Minus tangent of 30 is root 3 over 3 divided by 1 plus, again, tan of 45 is 1 times tan 30, again, is root 3 over 3. Okay? So we essentially have, if I get common denominators here, which again, I'm going to have to multiply this by 3 over 3 and this by 3 over 3 to get common denominators. This is going to give me 3 minus root 3 over 3 divided by 3 plus root 3 over 3. Now, I've got some reducing to do, some radical work, if you will. So, remember, if you divide two fractions, you're multiplied by the reciprocal. So I'm not going to go into every little step of that. You guys have seen me do that many times. These 3's are going to cancel, and I'm going to be left with 3 minus root 3 over 3 plus root 3. Now, I have to rationalize the denominator. If you all remember how to do that, you have to multiply anytime you have a radical as part of a binomial. To rationalize the denominator, you have to multiply the top and the bottom by the conjugate of that binomial. So I have to multiply top and bottom here by 3 minus root 3. Okay, now FOIL the top, FOIL the bottom. Okay, so this gives me 9 minus 6 root 3 plus 3 over 9 minus 3 on the bottom. Okay, now this, if I combine like terms here, I've got 12 minus 6 root 3 over 6. Well, cancel out here. Okay. Actually, let me factor first. So I factored a 6 out of both terms on top. Then my 6's will cancel, and I am just left with 2 minus root 3. That would be my answer. Now, I know that was a little more difficult than the first sine and cosine when we did. Tangent usually is. But that gives you the step-by-step that we did here. Again, let me remind you that you are like foiling these. Okay? Foiling top and bottom. That's how I got the next step. Okay. Next problem. Now they've kind of resorted back to radians here on number 6. So number 6, I have sine of 43 pi over 12. Woo! Okay, well, 43 pi over 12 is way more than 2 pi. Okay, remember, one whole revolution around your unit circle is 2 pi radians, right? So if I subtract 2 pi radians, but 2 pi with a denominator of 12 is 24 pi over 12. So if I subtract 24 pi over 12 from 43 pi over 12, I'm left with sine of 19 pi over 12. That's the first thing, is get rid of one whole revolution around the unit circle. Okay, we don't need the extra, if you will. And again, that's 43 minus 24. 24 is twice 12. Okay, now, from this, quite honestly, I think it's easiest to see it as a degree measure. Okay, so if you remember to convert from radians to degrees, okay, from radians to degrees, you multiply by 180 over pi. Okay, so 19 pi over 12 times 180 over pi. Of course, my pi's are going to cancel. If I poke that in my handy dandy calculator, I get 285 degrees. Now that should look familiar. We just had other problems in the first 4 that had 285. So now what I really have is sine of 285 degrees. Again, we've seen that before. Sine of 285 degrees is sine of negative 75 degrees. Again, sine of negative 75 degrees, sine is an odd function. So this is negative sine of 75 degrees. Okay, I'm not going to go through the sum formula again because we already did it. But the sine of 45 plus 30, if we go through the formula, which, anyway, for the sake of time, I'm not, it's going to be minus root 6 minus root 2 all over 4, the big fat negative in the front of it. Okay, and again, that was like the third problem I did, I believe. Okay, so back towards the beginning of the video. All right, let me just put, you can use your sum formula on that. Okay, we already did that, so I'm not going to go through it again. Okay, next one, kind of the same type of thing. We have cosine of 29 pi over 12. Well, again, if I take out a 2 pi out of that, 2 pi with the denominator of 12 is 24 pi over 12. So if I take 29 pi over 12 minus 24 pi over 12, I get cosine of 5 pi over 12. Then, if I convert that to degrees, 5 times 180 divided by 12 is cosine of 75 degrees. Once again, we've seen that before. That seems to be a recurring theme here. So, cosine of 75 degrees is cosine of 45 degrees plus 30 degrees. Okay, use the sum formula. Now, again, I'm not going to do it again. It was like the third or fourth problem we did from the beginning of this video. So we already have the answer to this. That is root 6 minus root 2 all over 4. And you know what I just realized? I realized I screwed up on the previous one. Let me go back. This should be a plus. I apologize. That should be a plus. Whoops. That should be root 6 over 4 plus root 2 over 4 is how we got that. And then the minus is out front. I apologize. I missed it. Because cosine gives us the minus in the middle. Sine gives us the plus. So that was number 7. Okay, just a couple more, but I think I'm going to split this video out into 2 pieces. So I'm going to quit here and do the last 5 in the next video. So hang tight for part B of 7.2.